Hello students. So air is made up of different gases. Along with all the other gases, water vapor is also present. So what is the proof? For example, students, take a glass, normal empty glass, and add some ice cubes into that glass, or add some chilled water into that glass. What you will observe? You can observe that, the small droplet formation on the outer surface of the glass. Yes or no? What is the reason for that? Is the inside water coming outside from inside to the outside? No. Why? Because the reason is the water vapor present in the air, when it touches to the cold surface, it condenses. If it condenses, it becomes into a droplet. That means vapor changes into liquid. Understood? Condensation. So that is a proof. So water vapor is also present in the air, students, along with all the other gases like nitrogen, oxygen, carbon dioxide and all. So like how do we get this water vapor at this normal conditions of temperature? Water's boiling point is 100 degrees Celsius. So the water vapor is because of the process called as evaporation. Students, due to the evaporation, the surface water molecules slowly escape into the atmosphere, into the air, by getting rid of the intermolecular forces of attraction. So let's discuss the remaining gases which are present in the air, as well as impurities, dust particles, pollutants, everything. So this chapter will be completed. So first of all, water vapor. So what is the formula of water vapor? The formula is H2O. Yes or no? The amount of water vapor in the air is called as humidity, one of the main factor even to measure the climatic conditions or the weather conditions. So its amount can be determined with the help of hydrometers, and it varies from place to place. As in the coastal areas, there is more humidity. In other areas, there is less chance for humidity, right? So it depends upon the place, and it depends on the time also. So that's all about water vapor. And let's see some other points, like water vapor in the air condenses continuously to form small drops of water. These droplets join together and grow in size. Finally, they come to the earth. So the whole process is known as precipitation. Rain, drizzle, snow, hail are the main forms of the precipitation. So student, the presence of the water vapor completely the main cause for the water cycle in the air. Not only air means air and water droplets, rain formations, cloud formations, evaporation. It's a completely cycle, water cycle. It is called as water cycle. What happens? So the surface water from all the water bodies like rivers, lakes and oceans, everything, water evaporates. Yes or no? The evaporated water, where it goes to, and it simply rises up. If it rises up at the higher altitudes, the temperature is very low. It will slowly condense, and it will condense, and it forms very, very tiny droplets. It forms very, very tiny droplets of water, and these tiny droplets are guided by some force of attractions, and it forms a shape that is called as cloud. And when the temperatures were cooled down very low, these tiny droplets connected with each other, and they form a big droplet of water, H2O. So that drop of water, and it falls down. That is called as rain. So then the process is called as precipitation. So the rain comes down, again it fills all the water bodies, again evaporation. It's a completely cycle. Evaporation, condensation, precipitation, transpiration. Also the excess H2O can be released by the plants also, students. So that's a completely cycle which maintains in our earth condition. So not only that rain, sometimes in the small droplets, drizzle, snow or hailstones also, depends upon the climate conditions at that moment. We can get that based on ultimately coming from where? From the water vapor only. What is water vapor? H2O, gaseous form of H2O, right? Next, noble gases. What are noble gases, students? So a group of gases, a group of elements which are completely unreactive. Why these elements are completely unreactive? First, what are the elements? Helium, neon, argon, krypton, xenon and radon. So these are the noble gases, right? They are completely unreactive because they have completely filled valency shell configurations. They all have 8 electrons in their valency shell. That's why they're completely unreactive. There are some exceptions also, like xenon. So a group of gases which do not react chemically with any other substance are called as noble gases or inert gases. They are helium, neon, argon, krypton and xenon. They are also present in the air. Mostly argon percentage will be more, but these gases are also present in the air along with all the other gases. So we have some uses of noble gases. First of all, what's the first use? In balloons and airships, mostly helium is used, students. Helium, atomic number 2, its mass number 4. Helium is one of the lighter gases. Sir, no. Have you seen this air balloons? Air balloons which used to move from one place to the another place. So these air balloons contains helium. Why only helium? Helium is a lighter gas. Here one doubt. Sir, why not hydrogen gas? H2, it's a 2 grams only. 1 mole. Yes or no? It's even more lighter than helium, correct? But hydrogen is a highly combustible gas, students. There is a chance for, a kind of burning. So, but helium, unreactive, non-combustible. So, there is no chance for this with the case of helium. It's a lighter gas. So, it is lighter than air, obviously. So, it simply rises up. So, it is used in balloons as well as airships also. In electrical lamps, like means in bulbs also, students, to maintain that inert atmosphere inside the bulb, these noble gases only used. Not only the noble gases, mostly in the noble gases, argon is most preferable. Sometimes argon is mixed with nitrogen also. Nitrogen also not 100% inert, but in general it is inert. It shows inert conditions only, students. It is chemically reactive only, but it is in general it is inert at the normal conditions. So to maintain the tungsten long lasting, we use these gases. What if any other gas, it may react with the tungsten? That's a problem. Understood? Next, in medicine fields also, medicine fields mostly radioactive elements are used, students, like polonium, plutonium, or radon is a radioactive element to target the cancer cells, the respective cancer cells. The radon is used in the medicinal industry. And in the sign tubes means, students, have you seen sometimes like in any restaurants, have you seen this in the cursive writing, some glow cursive writings are there, open, closed, that is filled with noble gases only. So every gas has its own characteristic color. Mostly it contains neon or argon. So it gives that bright orangish or violet color glowing light. So sign tubes are also mostly. So these are all the main uses of noble gases, unreactive gases. Along with this, we can also expect some impurities present in the air, students. The percentage of impurities in the air is variable depending upon the location of the place. In general, the air contains large amount of impurities in the industrial areas. For example, there is a mining place. How many impurities are there? Many impurities. So it depends upon place to place. Some green park is there. Can we expect more impurities there? No. A big machinery happening, work is happening there. There is a chance for more impurities. Dust particles, smoke particles, all comes under impurities only. So dust particles, same. Smoke are the impurities present in the air, and excessive amount of these can cause serious respiratory problems. The excess amount of anything can cause serious lung issues, students, respiratory problems also. That's why when you're subjected to these dust particles or smoke particles, you have to maintain a safety things. Otherwise, they can cause serious respiratory issues. So air pollutants. Air pollutants are the undesirable gases and particles present in the air. These include carbon monoxide, CO, sulfur dioxide, SO2, and oxides of nitrogen, dust and soot. These pollutants enter the air when they are released as a product of various industrial activities and burning of fuels, and can cause air pollution. So air pollution means mostly it is pollution for us. If it is in the air, nothing happen. Why we are calling it as a pollution? Something happens to us because of the presence of these harmful gases, students. So what are the harmful gases? Carbon monoxide, sulfur dioxide, nitrogen dioxide. What is the harmness they can cause? That we'll discuss in the slides. First, carbon monoxide. What is the formula? CO. So carbon monoxide is formed as a result of the incomplete burning of the fuel. Students, any fossil fuel like any hydrocarbon, if you burn hydrocarbons, what do we get? Carbon dioxide. If there is insufficient amount of oxygen present, if there is presence of insufficient amount of oxygen, then we can expect carbon monoxide only. So in that case, this CO is released, and carbon monoxide is a toxic gas. It has no color and no smell. So we can't even identify also that we are inhaling carbon monoxide. So mostly where it can be released. So mostly it is released by the vehicles which are out of condition, or by some kind of industries. This gas can be exposed. Overexposure to this carbon monoxide can cause death also. Toxic. It's a purely toxic gas, students. It can form harmful complexes with our biological system, with the blood. So carbon monoxide is very, very harmful. where it is produced by the incomplete combustion. Sometimes while going on the roads, you can see some kind of big lorries or some kind of autos, they release black smoke. Yes or no? That is very, very harmful. That contains pure carbon dust particle. That is the carbon particles only. That even contains carbon monoxide also. So exposure to that directly doesn't mean directly if you inhale that no sudden death, but long exposure to these gases, for over a long period of time, completely it is problematic gas. So be careful. Next, sulfur dioxide, SO2. Mostly student, this sulfur dioxide gas also can be released by the burning fossil fuels. Sometimes sulfur can also be trapped into this fossil fuels, as well as based on the sulfur manufacturing industries also releases sulfur dioxide gas. It is released into the air when fossil fuels are burnt. This pollutant is present in the large quantities in chimney emissions from the thermal power stations, petroleum refineries and fertilizer factories. What are fertilizer? Sulfates. Yes sir, no, there is sulfur present, right students? And some industries which they manufacture sulfuric acid. So there is sulfur, and thermal power stations in the process of producing energy from the fossil fuels. Fossil fuels mostly made up of carbon and hydrogen also, but there are traces of sulfur, oxygen and nitrogen also. So in all these cases, sulfur dioxide gas is released. That is also harmful. That is also comes under pollutant gas, toxic gas, students. So next, oxides of nitrogen. What are the oxides of nitrogen? We have NO, nitric oxide, NO2, nitrogen dioxide, and N2O, nitrous oxide. Like that, we have some oxides of nitrogen. So nitrogen is not a very reactive gas. Nitrogen means N2, students. However, it can combine with oxygen at high temperatures and forms oxides of nitrogen. Apart from that, automobiles, oxides of nitrogen are also emitted by the factories which manufacture nitric acid. What is the formula of nitric acid? HNO3. The factories with the synthesized nitric acid. Why is nitric acid? Many uses are there. Nitric acid is used in the preparation of fertilizers, explosives, and it is used as a reagent in many organic reactions also. So that kind of factories, we can expect the oxides of nitrogen into the atmosphere, which is a pollutant. That's why we are discussing here, which is a toxic gas. So that manufacture nitric acid and such other chemicals also. Next, dust particles and soot particles. What is dust? And dust means we already know. What is it? Soot, that we'll discuss. Small amount of dust particles which do not harm. As a matter of fact, they help in the precipitation of water vapor and hence in the formation of clouds and rain. So small amount of dust particles that doesn't matter, students. But even dust particles means, like I said, like I mentioned, mines are there, like some mineral mining is happening, large amount of dust particles are there. Overexposure to that kind of dust particles is also a serious threat for us, for our lung issues, respiratory problems, many. Normally in general, while on the roads in the living residential areas, nothing will happen with the normal dust particles. So however, an excessive amount of these can cause serious respiratory problems, right students? Clear? And soot is nothing but, we'll discuss here, SPM, suspended particulate matter. When fuel burns in insufficient amount of oxygen, some carbon may escape from burning. This carbon forms soot, students. For example, just now I have said in the previous slides, so insufficient combustion of petrochemicals, what we can expect? Carbon monoxide. If there is very less amount of oxygen, students, in that case, some carbon may escape without burning also. For example, students, have you seen sometimes while burning the candle, during the puja times also, you can see some black coating will appear on the roof of the particular place. Yes or no? If you scratch that black coating, what you will get? A black powdery substance. What it is? Carbon only. That is carbon only, students. Escaped carbon. Normal candle also, you can see a black smoke on the top of the flame. Yes or no? Coming out. If you keep your hand not on the flame, don't keep your hand on the flame. On the top of the flame, a black coating will appear. Yes or no? What is that? Carbon. They are the carbon particles. So these carbon particles, where they are escaping into the air only, na students? So these carbon particles are coming only from candle? No. These carbon particles are all coming from all the vehicles or industries also. Like I said, some out of condition vehicles, they release black smoke that contains carbon. So which is very, very dangerous. So directly it enters into our body, settles in our tissues, and it will try to damage the tissue. So serious lung issues mainly happens with these dust particles and soot particles. Soot means the black powdery substance called as carbon. So the dark smoke that comes out from the chimneys contains minute particles of ash and carbon. The smoke from the buses, trucks and generators primarily contains unburned carbon particles. The finer the particles, the more harmful they are because they cannot filtered by the nasal hair, and when they deposited on plant leaves, these particles hinder photosynthesis. For example, students, have you seen sometimes roadside plants, the leaves are filled with dust particles, yes or no? For them the photosynthesis is very slow. Understood? Why does it happen? Does it happen the over exposure to the sunlight all the leaves? No. So that hinders the photosynthesis also. Of course they can cause serious health problems for us, also for the plants also, that are directly settles on the plant leaves, and the exposure to the sunlight to that pigment will be hindered. So that's a problem with this SPM called as suspended particulate matter. So what are the hazards of air pollution? Like what are the side effects? Acid rains. So like we discussed about this carbon dioxide, sulfur dioxide, nitrogen dioxide, nitric oxide, all these oxides we are saying harmful respiratory problems. Yes sir. Not only that, students, they can cause acid rains also. How? Let's see. Acid rains is formed when sulfur dioxide and oxides of nitrogen in the atmosphere dissolves in rainwater. Sulfur dioxide, students, it enters into the atmosphere. In the atmosphere, water vapor is present. Sir, what is the formula of water vapor? H2O. SO2 plus H2O gives rise to what happens, students? H2SO3, sulfurous acid. If it is sulfur trioxide, look at the reaction. SO3 plus H2O gives rise to H2SO4, which is sulfuric acid. This sulfuric acid combines with the remaining water which is present in the air, students, like during the rain formation, and it falls as rain. That rain is called as acid rain. The rain which contains acid. Where does this acid comes from? From the oxides of these non-metals only. These oxides combines with water and they produce the respective acids, right? So what are the effects that we'll discuss? Look at the other acid. NO2 plus O2 plus H2O gives rise to HNO3, which is nitric acid. If it is CO2 plus H2O, what we can expect, students? H2CO3, which is carbonic acid. That is also acid, of course, weak acid, that one. These are strong acids. So what are the effects of these acid, students? When the acid rain happens, of course, directly when we are exposed towards acid rain, so the ones who are very sensitive skin issues, they can cause serious skin issues also, skin allergies also. And if they fall on the on the ground, what will happen? The acidity of the soil will increases. As students, acidity, the soil becomes more acidity, right? Why? Because acid, it contains the acid. As well as when this water enter into the nearby lakes, ponds, the acidity of the lakes and ponds also increases or not? They become more acidic or not? And that will be hard for the survival of aquatic life. Why? Because we are all living in a particular pH range. If that pH range is disturbed, that is not good for the survival. So aquatic life will be disturbed, plant life will be disturbed, everything will be disturbed because of this acid rains. Even monuments which are made up of limestone also, they can cause a serious threat. Why? Because they completely react with carbonates. Acids react with carbonates, they produce the respective salts and they release carbon dioxide. These are the effects of acid rains. Where these rains are coming from? By acid formation in the air. How? By the oxides of sulfur, nitrogen and carbon, right? So next, greenhouse effect and global warming. What is a greenhouse effect? Students, listen. Land and ocean absorb solar energy, right, clear, to warm the earth atmosphere. In turn, they releases IR radiations, infrared radiations or heat into the atmosphere. The blanket of gases covering the earth's surface traps these radiations. So students, listen. All our the land area, the water surface completely absorbs the sun rays, right? Becomes heat, becomes hot, and again they emit radiations. These radiations will be trapped by the gases present in the air. That's what happens. That is called as greenhouse effect. And because of this trapping, we can maintain the ideal temperature. The earth can maintain ideal temperatures throughout the nights also. Otherwise, if this is not happening, during daytime ideal condition, okay, but during night time, what happens, students? The earth becomes very icy cold at the night time, the other part of the earth which is opposite towards the sun. So it becomes icy cold. But is it happening? No, because of greenhouse effect only. because of trapping that heat energy. Even the night times also we can have this ideal temperature ranges around 20 degrees Celsius. I'm not talking about the polar regions and all other countries, in general, students, in general. So ideal temperatures will be maintained. So that effect is called as greenhouse effect. But why we are talking about that effect? Why? Because students, the problem with CO2. So the blanket of gases covering the Earth's surface traps these radiations, right? Correct. Thus absorption of heat maintains the temperature of the Earth's surface, which is absolutely essential for the support of the life. That is good for the planet Earth. And this natural process is called as greenhouse effect. This natural phenomenon of greenhouse effect is caused mostly by the CO2 and water vapor in the atmosphere. Hence, these gases are called as greenhouse gases. These gases are called as greenhouse gases. Then, but what is the problem? The problem is, students, CO2 percentage is around 0.03 to 0.4 percentage in our air. We are burning all the fossil fuels, yes or no? That in turn what happens? CO2 levels are increasing. If the CO2 levels are increasing, now answer, more energy can be trapped, yes or no? More energy can be trapped. That means in general, Earth, in the planet Earth, the temperatures will be rises, yes or no? More is the trapping the energy. Sir, why? More is the CO2 levels. If more is the energy gets trapped, the temperature rises, the globe becomes warm. That is called as, that effect is called as global warming. So melting of ice caps and glaciers, excessive evaporation in the sea and ocean water increases the frequency of floods, soil erosion, unseasonable rains, health hazards for human beings and animals are some harmful effects of the global warming. Because of this global warming, students, because of this global warming, you know what happens? So the ice, because of the temperature rises, the polar ice cap will be melted. That increases the sea level, yes or no? That can cause devastating effects to our environmental conditions. Weather patterns will change, everything will be gone. So next, ozone depletion. Depletion of ozone layer. So what is ozone? What is the formula? O3. Ozone is O3. So how it is helpful for us? You know, students, ozone can filter the Earth's atmosphere from the UV radiations, from the ultraviolet, harmful ultraviolet radiations. Sir, what happens if they come and strikes to the plant life and animal life, everything? They can cause serious health problems, skin cancers, everything. So this ozone is getting depleted. Not now, students, in the 10-15 years back, the ozone layer gets depleted. Now it's got healed also. Then why? What is the primary reason for this ozone depletion? We have to know that. Ozone layer acts as a screen for harmful ultraviolet radiations coming from the sun. Some pollutants such as CFCs, chlorofluorocarbon, students, are chemically inactive and do not dissolve in rainwater. That means the moment when these chlorofluorocarbons enter into the air, they are not reacting with H2O. They do not dissolve in water. Unlike other oxides of sulfur, nitrogen and carbon, they directly enters into the stratosphere, and hence they reach the stratosphere, react with ozone, can cause depletion of ozone in that region. That means, for example, CO, carbon monoxide, CO plus O3 gives rise to CO2 plus O2. That means O3 molecule is getting reacting or not. That's the problem. So once these radiations reaches the Earth's surface, it causes many undesirable effects like skin cancer, damage of plants, crops, everything. The whole life will be, students, will suffer a lot because of these UV radiations. So prevention of air pollution, we have 2 points, students. How can we prevent this air pollution? As far as possible, lead-free fuel such as compressed natural gas like CNG should be used for running cars, buses and trucks. The vehicles should be subjected to the stringent air pollution checks. Similarly, we should be vigilant about the polluting industries units. That means we have to be very careful about the conditions of the particular vehicles, two-wheelers, four-wheelers. Why? Because they release an enormous amount of smoke into the atmosphere, as well as industries also. So how much smoke is getting released, how much they're releasing into the atmosphere, we have to careful. Of course, not we. Government has to take an initiative about all these things and shift to using the less polluting forms of power generation such as solar energy, wind energy, tidal or geothermal energy. Use of other forms of renewable energy may also be explored. The use of fossil fuels should be reduced to minimum. Smoke precipitators should be installed in all the chimneys in factories and mills. That means students, all the industries should develop a technique in order to filter all these smokes. Directly they're releasing all the smoke into the atmosphere, which can cause serious health problems. So they have to adapt all these safety measures before releasing the excessive amount of pollutants into the air, into the water, everywhere. So all these initiatives should be taken by the government. That's it, students. This chapter is completed. We discussed about air and all the components of air, their chemical properties, physical properties, air pollution, prevention of air pollution, everything. I hope you got the clarity. Thank you, students.